Test, 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 test. All right. All right, let's get started. If you want to turn your homework up here, be nice. I'm going to pass out the homework at the end of class. Thank you. Thank you. Thank you. Thank you. All right, so people are going to filter in. Let me introduce myself once again. So I don't think I taught you guys last week because you guys are 9 a.m., but my name is Ivan Lee. I'm going to be a recitation TA this semester. It turns out that a lot of you guys already know who I am, and I know like none of you guys, so let's just keep this short. Let's have each one of you guys introduce yourselves. So let's do name, year, and what you're studying. This is very brief. Let's start here.
Sorry. I'm Leia. I'm a junior. I'm studying college sciences in college.
I'm Felix. I'm a freshman studying chemical engineering. I'm Ian. I'm a freshman. I'm studying bioengineering.
Jason. I'm a junior. I'm studying biophysics.
I'm Melina. I'm a freshman and I'm studying math econ.
I'm Alice. I'm a freshman. I'm studying biochem.
I'm Tara. I'm a freshman. I'm studying physics.
I'm already a freshman and I'm biochemistry.
I'm Lauren. I'm a freshman and I'm studying chem engineering.
I'm Kara. I'm a freshman and I'm studying this.
I'm Michelle. I'm a freshman and I'm studying bioengineering.
I'm Sue. I'm a freshman. I'm studying bioengineering.
I'm Connor. I'm a freshman studying systems.
Okay. So a lot of freshmen, a few more juniors here. My theory is that freshmen have no idea how to sign up for classes, so all of them got stuck in the 8 a.m. section, which generally happens. So yeah, the last semester I actually went around, and one question I asked was, why are you taking this class? And then kind of like bullied them into answering it's a requirement. So I'm just going to assume that all of you guys are taking this class as a requirement. No one's actually taking this class because they're interested in it, which is fine. It is what it is. So if you have homework, please hand it up here. So a lot of you guys might be, wondering like, why do we have these recitation homeworks and why is homework so freaking long? If you're a sophomore, you can go blame all your friends from last semester that took Math 240. But essentially, we had a much more lackadaisical kind of structure last semester in 240, and everyone just took advantage of it by like not showing up to class and then bitching about their exam grades at the end. So in order to like, front all that, we decided to make this semester a little more involved, and you have to put a little more work in. So it is what it is. These quizzes, these homeworks are in substitution of quizzes. So like the alternative is that we can give you a quiz at the end of each recitation, which everyone hates. I hate like wasting 10 minutes of my time at the end of recitation, and you guys probably don't like the unknown aspect of like what the hell's on this quiz. So instead we made these, I guess, a little bit too long of recitation homeworks, but you guys will have to deal with that. So, all right, that being said, I have some announcements we're going to get to at the end. Hopefully I have enough time to get to it at the end. You guys are the 9 a.m. section, so of course you guys are the recorded section. 8 a.m.s are the guinea pigs, but what's going to happen is I'm going to record your recitation, and then I'm going to upload it to my website on Friday, not today, so you guys can go and rewatch it if necessary. So that doesn't mean skip recitation and watch the recording, because you're not going to get the homework. So keep that in mind. All right, let's get started. We're going to talk about row echelon form and reduced row echelon form. First, so Quick disclaimer: one, my handwriting is absolute garbage, if you can't tell already. Secondly, I do end up using a lot of like abbreviations and stuff and like symbols. So if you have like absolutely no idea what I'm writing on the screen, definitely stop the class and tell me that my handwriting sucks and that I should rewrite what I just wrote. So, okay, so let's start with then the definition of row echelon form, which is REF. Okay, and the three conditions. So firstly, all rows of zeros are on the bottom. All right, 2, all non-zero rows must begin with a leading 1. And 3, the leading 1 of a row must be to the right of the leading 1 in the row above. Okay. So these are the three conditions. I could say a million words and you guys can not understand any of it, so let's go through some examples, which are the following. So 0, 1, 3, 0, 0, 1, 0, 0, 0. Okay, that works. Right, because if you see, right, each row goes with the leading 1, your row of zeros is on the bottom, and then this 1 is to the right of the 1 above it. Okay, so that's going to be that. And then you have something like 1, -2, 0, 7, 0, 0, 1, 4. Same idea. Here are your leading 1s, and then this leading 1 is to the right of the leading 1 directly above it. Okay, what is it not? So if you have something like 1, 1, -3, 0, 0, 0, 0, 1, 2, that's a 0. This guy's not row echelon form, and the reason is because that row of zeros is in the middle. All right, so you got to move that row of zeros down to the bottom. And then another one that's not row echelon form, so you have like 0, 1, 7, 1, -2, 4, 0, 0, 1. This one's not row echelon form because this 1 is to the left of that guy. All right, so it has to be to the right for it to be in row echelon form. Any questions? Okay. So that's row echelon form, so it's closely related is going to be the definition of reduced row echelon form. All right, and what's reduced row echelon form? There are two things. One, it's in row echelon form. All right, so it has to satisfy everything from row echelon form. And then the another condition that we're going to throw on top of that is any column with a leading 1 is 0 elsewhere. So what does that mean? If we go back up to these two examples of row echelon form, right, because that has to be what it is, this guy is not RREF. And the problem is because there's a 3 here and there's a leading 1 in that same column. Okay? Whereas, and somehow I didn't close that matrix, this second matrix is in reduced row echelon form because that column with a 1, with the leading 1 in it, has 0 everywhere else, and then this column with the leading 1 in it has 0 everywhere else. Okay? And it's important to note that a matrix A has many row echelon forms. All right, and you probably, if you've done some homeworks, or if you've done some homeworks, you've probably realized this by now, that the way you row reduce your matrix might be different from the way I row reduce my matrix, and we're just going to end up with different matrices. That's fine. However, a matrix A has only one reduced row echelon form. So if you reduce it all the way down to reduced row echelon form, everyone should get the same answer. All right, and so we call this the unique reduced row echelon form, unique RREF. All right. Any questions? Okay. So let's talk about rank and pivots now. So this is, I think, 2.4. So let's give the definition of rank. So rank is the number of non-zero rows in row echelon form of a matrix A. So if we reduce A down to some row echelon form, the rank is the number of non-zero rows. All right, so any rows that has something in it. So for example, all right, if I have, let's see, like this identity matrix, which is just 1 on the diagonal and 0 everywhere else. All right, so that's the identity matrix. Usually, for these like diagonal type matrices, I'm just not going to put like entries anywhere. That just means it's 0. Okay, so this is 1 on the diagonal, 0 everywhere else. Let's say this is n by n. All right, what's the rank of this matrix? N. All right. Now let's do this thing. All right, we already talked about this above, I think. What's the rank of this matrix? 2, right? So it's not quite in row echelon form, but it's pretty clear how we're going to get to row echelon form. We're just going to divide this middle row by 3, right? And then we'll get a 1 here, and then we'll be in row echelon form. So it appears then that there's a way of us telling what the rank of a matrix is without quite getting to row echelon form. And we'll talk about that in just a second here. All right, so that's 2. So now let's talk about this matrix. All right, 2, 1, 1, 1, 4, 0, 2, 0. Okay, so that's going to be a matrix. All right, what's the rank of this matrix? So, okay, we'll have a poll. How many think of you it's 2? All right, so 2. All right, it's the rank 2. All right, how many think the rank is 4? 4, 4, 4, 4. All right, how many think of you it's less than 2? All right, that's fine. So again, what's the definition of rank? The rank is that you have to be in row echelon form, right? So we got to actually reduce this matrix. So I'm going to do some really sketchy reducing here. So how are we going to do this? So this is going to be 1, 1, 2, 1. So I flip the first 2 rows, and then I'm just going to divide these guys by their relevant constants to get to 1, 0. All right, so the third row I divided by 4, the last row I divided by 2. We'll get to 1, 0. Okay, so that's what I have, and then I got to reduce it more. So now 1, 1. This is going to be 0, negative 1 up here. All right, because what I did was I took this and I subtracted 2 times the row above it, and then 1, 0. And then one of the 1 zeros is going to kill the other 1 0. So that's going to be a row of zeros on the bottom. Okay. And then we're going to reduce this more. 1, 1, 0, negative 1. Now I'm going to take this guy. I'm going to subtract that row. I'm going to get 0, negative 1. And then finally, we see that this is going to be 1, 1, 0, negative 1. And then that third row is going to get killed by the second row as well. All right. So what's the answer? The answer is the rank is 2. Okay, and this leads me to then my first important point of the day, which is the following. For an m by n matrix, all right, so m rows, n columns, the rank of A has to be less than or equal to the minimum of m or n. All right, so if we take that into consideration over here, right, this has 4 rows and 2 columns. Okay? So what's going to happen is that this rank is going to be less than or equal to the minimum of 4 rows or 2 columns. Well, that means the rank has to be less than or equal to 2, and there we see it. We have the rank is 2, right? So 4 really wasn't like a possible solution to even begin with. Okay. Any questions? All right, let's move on. So let's take a look at the second. So in the second matrix, right? We kind of just looked at it and we were able to give a rank. So when can we actually do that? So first, let me define what a pivot is. So definition of a pivot, and this is just a really hand wavy definition, but we're just gonna say it's where a leading one should be. Okay. So it's where it should be. So let's take a look at some examples. EX. All right, so I got 1, 1, 1. Right, got the identity matrix, a 3x3 identity matrix. Where are the pivots? Well, you already have the leading ones, but those are your pivots, right? And for each column that has a pivot, we're going to call it a pivot column. So that's a pivot column, that's a pivot column, and that's a pivot column. All right, so that one was pretty easy. So now if we go up to this guy, which I'm making a big fuss about, right? Let's take a look at where the pivot columns are here. Well, we said earlier that, okay, this guy's a leading 1, so that's a pivot. The second row, if we divide it by 3, we're going to get a leading 1 there too, right? So this 3 is going to be a pivot as well. But do I have any more pivots? No. Right? There's no pivot in this last row. You can't pivot on a 0. So I have 2 pivot columns, and then the not pivot columns, we're going to call them free columns. All right? And the reason we call them free columns is the idea that when you're solving a system of equations, your free columns correspond to free variables. All right. And then for these first few examples, we've been a little bit, I've had the pivot column. The first column is always a pivot column. Doesn't have to be the case. So you can have something like this. All right. So this matrix then, where are my pivots? Well, it's going to be this 5, all right, this 2, and this -3 right here. All right. And that means the first column is actually a free column. So here are my pivot columns, the 2nd, 3rd, and 5th. And then my 1st and my 4th columns are going to be free. Okay. Any questions? So why do we care about pivots? The idea then is the number of pivots is equal to the rank of a matrix. Okay, so you don't have to quite get down to row echelon form to get the rank of the matrix, but you do have to what we call expose the pivots. All right, as in you have to be able to tell where the pivots are. Okay. If there are no questions, we'll move on. Let's move on then to section 2.5, which is Gaussian elimination. And this is what you guys did in class, I think. Yesterday? Okay, so what Gaussian elimination is essentially we're solving systems of equations by reducing matrices to row echelon form. But as we can tell from above, we don't technically have to get it to row echelon form. If you have it in like where the pivots are exposed, that's good enough. But that's the formal definition. Or it's not even definition, but it's somewhat formal. So, all right, let's make this table then. We're going to refer to this table a lot. So it's going to be the relationship between the number of solutions of an equation in a system of equations, the rank of A, we'll get to what that means in a quick second, and the rank of A augmented. Okay, so we'll get to what A and A augmented are. So if we think about a system of equations, let's think about, right, for homework 0, you had to do all this intersections of planes in space. So if we have 3 planes in space, right, how can they intersect? Well, they can intersect at a point. So how does that work? Well, let's say, right, you have this. So the screen's a point. This bottom is a plane, and then I put this plane here. They're going to intersect at one point, which is in the corner. I don't know if you guys here can see it, but maybe like this. Right? So they're going to intersect down here. Right? So this is 3 planes intersecting at one point. Right? They can intersect at a line, so something like that. Right? That's going to be intersecting at a line, or they can just not intersect. So if you treat this back as like another plane, right? You're going to see that these 3 planes don't intersect anywhere. All right? So that's going to be 0 solutions. All right? And then if they intersect at a line, that's infinite solutions. And then if they all intersect at one point, that's going to be exactly 1 solution. All right? So in general, even when we generalize to higher dimensions, that's going to be the case. We're going to either have 0 solutions, 1 solution, or an infinite number of solutions. Okay? So let's take then a look at an example 1, of a system of equations. So we're going to write it out. 2x1 plus x2 plus 5x3 plus 3x4 is equal to 1. x1 plus 3x2 plus 2x3 plus 4x4 is equal to 3. All right, I'll shut up now. 5x2 minus All right, that's our system of equations. As Professor McGrath did in the first lecture, he actually just rewrote the x1s, x2s, x3s, x4s like over and over and over and over, but we know by now that that's just a waste of time. So we're going to put this into matrix. So all we care about are the coefficients. So from first row, we have 2, 1, 5, 3. And then that equal sign is this big-ass vertical line in the matrix. And then on the right-hand side, we have 1. All right. And then the second row is going to be 1, 3, 2, 4, 3. And the last row is 0, 5, negative 1, 5, negative 2. All right. Now what? So this matrix right here, this is going to be A. All right. So A is always going to be like these guys, not including the equal sign stuff. And then A augmented is going to be everything, all right, including what's on the right-hand side of the equal sign. So what we're going to do is that we're going to row reduce this guy until we can find a solution. So I'm going to flip the first 2 rows first. All right, so row 2 becomes row 1. Row 1 becomes row 2. All right, and the idea is you want to get this 1 in the top left usually. All right, the next step is then to get zeros below that 1. So we copy the first row. And then we'll do something like row 2 replaced with row 2 minus 2 times row 1. right? So that's 0, and then now I get 1 minus 6, which is negative 5, 5 minus 4, which is 1, 3 minus 8, which is negative 5, 1 minus 6, which is negative 5. And then I'm not going to bother with the last row for now. Okay, so the goal here was to get zeros here. Now what? Now I'm just going to, well, so these two rows here, these guys look awfully similar, right? They're off by a factor of negative 1. So I'm just going to add the last row to row 2. So I'm going to do row 3 replaced with row 3 plus row 2. So the first row stays the same. The second row stays the same. And then the third row, I'm going to add it to row 2. So I'm going to get 0, 0, 0, 0. And then negative 2 minus 5 is negative 7. Okay, so what does this last row tell me? So remember, we went from this gibberish of a system of equations. We placed it in this matrix. So this last row is actually telling me that 0x1 plus 0x2 plus 0x3 plus 0x4 is equal to negative 7. Is that possible? No, right? Everything's just getting multiplied by 0. So yeah, this is not possible. There's no solution here. Well, you don't have to do that. So there's no solution to this system of equations. Okay, so that's cool. What are we trying to show in the first place? Well, remember, we have this relationship between the rank of A and the rank of A augmented that we want to talk about. So what's the rank of A and what's the rank of A augmented here? So what's rank of A? 2. And what's the rank of the augmented matrix? 3? 3? All right, and so why? Well, okay, so we row reduced stuff already, right? But where are my pivots? My pivots are here, here, and here. Right? So pivot, pivot, free, free, and then there's another pivot down there. So for A, remember A is everything before that vertical line. Well, how many pivots are there? There are 2 pivots, right? And remember, the number of pivots is equal to the rank of a matrix. So that was the important point we're talking about up here. Right? Number of pivots equal to rank. So in this case, the rank of A is equal to 2. And then remember, A augmented is the entire thing. What's the rank of the augmented matrix? 3, right? Because I have 3 pivots as circled in the picture. So rank of A augmented is 3. So there's no solution, but what's the relationship then between the rank of A and the rank of A augmented? Yeah, so it's A plus 1, but more generally, it's just bigger. So, right, it's bigger. All right? So if the rank of the augmented matrix is bigger than the rank of A, then you're not going to have a solution. So if we go back up to then this first matrix here, or this table, so if you have 0 solutions, right, there's no solution, rank of A is less than rank augmented. Okay, and I guess I didn't write this. I should have. Assume A is an m by n matrix, like usual. So assume A is m by n. So notice for 0 solutions, we don't even care about the dimension of the matrix, right? All we have to do is just look at the rank. All right, any questions? Let's move on. Example 2. is the following. So instead of writing everything out, we're just going to write the matrix form. So 1, negative 1, 0, 1, negative 1, 0, negative 1, negative 2. All right. Okay, so this is our system. All right, let's row reduce. So switch rows to get that 1 in the top. Just switch the first and the second row. So we get the 1 up here. Okay. Next step. Want to eliminate these guys. So how are we going to do that? Row 2 is equal to row 2 minus 4 row 1. And then row 3 is equal to row 3 plus row 1. Okay. So I get 1, negative 1, 0, 1. That stays. Here I get 0. All right. Negative 2 minus a negative 4. That's plus 4. 2, 3, negative 4. And then on the bottom, if you add row 3 to row 1, you get 0, negative 1, negative 1, negative 1. Okay, I'm going to do like 2 steps at once, which isn't really recommended, but it's okay. So row 1 is going to stay the same. I'm going to move row 3 to row 2, but I'm also going to simultaneously multiply by negative 1 because I really don't like all those negative signs. So this is going to be 0, 1, 1, 1. Okay, and then this becomes 0, 2, 3, negative 4 on the bottom. So I forgot to say up here we got zeros there, and then here you want a 1 here. And then now what? 1, negative 1, 0, 0, 1, 1, 1, 1. And I'm going to do row 3 replaced with row 3 minus 2 row 2. So I can zero out that guy, that 2 on the bottom. And now I get 0, 0. All right, 3 minus 2 is 1. Negative 4 minus 2 is negative 6. All right, and now we can back solve. So what does row 3 tell me? Row 3 tells me that x3 is equal to negative 6. All right, so that's what row 3 is saying here. Row 2 is talking about x2 plus x3 is equal to 1. Well, we know that's x2 minus 6 is equal to 1, so x2 is equal to 7. And then row 1, you have x1 minus x2 is equal to 1. Well, x1 minus 7, since x2 is 7, is 1, so x1 is 8. And we end up with the solution x is equal to x1, x2, x3, which is 8, 7, negative 6. Any questions? All right, how many solutions are there? 1. Okay, so there's 1 solution, and so when there's 1 solution, or we say there's a unique solution, all right, so that's just some vocab being thrown at you. So there's a unique solution, and okay, what are the conditions then for there to be a unique solution? What is rank of A? Yeah, it's 3, right? So if we go up here and we look at the rank, right, all your pivots are to the left of the vertical bar. So rank A is equal to 3. Actually, let me write that in a different color. What did I use up here? Use purple. So rank A is equal to 3. What's the rank of A augmented?
So 3.
Yeah, it's also 3, right? Since A augmented is just this entire matrix while all the pivots are here. Okay? So what do we notice? They're equal. And there's a solution. Right, so going back to that table then, when there's one solution, apparently the rank of A is equal to the rank of A augmented. Any questions? All right, let's keep moving along. So now, example 3. 1, 2, 1, 3, 3, negative 1, negative 2, 1, 1, 3, 2, 4, 0, 2. Okay, so this is our system. We're going to reduce 1, 2, 1, 3, 3. Right? How can I reduce this? Row 2 gets replaced with row 2 plus row 1. Row 3 gets replaced with row 3 minus 2 row 1. So now, I get 0, 0, 2, 4, 6. And on the bottom, I get 0, 0, negative 2, negative 4, negative 6. Okay? All we were trying to do was get zeros there. But, you know, by coincidence, these guys became 0, but that's just a coincidence. All right? That's just the way this problem was set up. But we weren't, the goal isn't to eliminate this block. It's just to eliminate that first column. Okay, so what now? So whenever you have like 2 columns or 2 rows that are just multiples of each other, you can just kill one of them, right? And you just make one of them 0. So we're just going to make the last row 0 here. And then we can pretty much solve for this system now, but let's just make it into row echelon form. So 1, 2, 1, 3, 3. And then divide this middle row by 2. 0, 1, 2, 3, 3. And then that last row of zeros. Yeah.
I think you wrote the last matrix wrong. I think it's going to be 0, 0, 2, 4.
Oh, 0, yeah, 0, 0, 2, 4, thank you. Yeah. So that's like the biggest threat to these kinds of problems is just making really dumb arithmetic mistakes, and it happens all the time. All right. So for this problem, kind of have to be careful with our equations because it's not immediately clear what our answers is. We have four unknowns and 2 equations pretty much, right? So this is the case then where we got to label our pivot columns and we got to label our free columns. All right, so we have 2 pivot columns, we have 2 free columns. So what I'm going to do then is for every free column, I have to give that variable like a parameter. So this free column, this is the x2 variable and this is the x4 variable, right? So what I'm going to have to do is I'm going to have to say, okay, let x2 equal t and x4 equal s. All right, and the reasoning is because if there's no pivot column there, those values can kind of take on anything they want to. So when you say t and s, that just means, hey, just any real number, plug it in, and we'll figure out what the solution is. All right, so now we have x2 and x4. We gave it these. We gave them these parameters. Now what? Well, now row 2 tells me that x3 plus 2x4 is equal to 3. So what does that mean? It means x3 is equal to 3 minus 2s. Right? You move x4 over to the right-hand side, and you substitute x4 with s. All right, so that's about as good as we can do. And then from row 1, you get this jumbo, x1 plus 2x2 plus x3 plus 3x4 is equal to 3. All right, now let's replace everything. No idea what x1 is. x2 is t. x3 is 3 minus 2s. And x4 is s. Okay, so all of that's equal to 3. All right, now what? Now you got to move everything over to the right-hand side except for x1. So you solve for x1, you get 3 minus 2t minus 3 minus 2s minus 3s. And once you resolve all the like terms and whatnot, you should get 3 or negative 2t minus s. Okay, so what's my solution? My solution is x is equal to negative 2t minus s, t, 3 minus 2s, and s. All right, that's my solution. And what is this? This is actually a plane in 4-dimensional space, also known as R4. Okay, so there's, how many solutions do we have?
Infinite.
Yeah, we have an infinite number of solutions, right? Because I can make T and S be literally anything I want, and all of those are going to be a solution. So here we have infinite numbers of solutions. All right, we have infinite solutions. What's the rank of A? I don't remember which color I used, but it's fine. So here's A. What's the rank of A? Yeah, the rank of A is 2. What's the rank of the augmented matrix?
2.
It's 2. All right, so they're equal to each other, but in the one solution case, they were also equal to each other. So what makes this different? Any ideas?
A is less than 10.
That's, you're thinking in the right direction. It's not quite right. How is this guy different from this up here? We have the ranks are equal. Oh, whoops. But one of them has a unique solution, and the other one has infinite solutions. All right, let me give you guys a hint. How many free columns did we have here, and how many free columns did we have up here? Right, so for the unique case, we had no free variables, right? So there are no free columns. And for the infinite case, we had 2 free variables. All right, so the idea is you actually want to look at the number of columns of A, and there are 4 of them. All right, well, 2 is not equal to 4. Up here, if we look at the number of columns, how many are there of A? There's 3, right? Well, now look at that. 3, 3, and 3, they're all the same. So what I'm trying to get at then is, let's summarize it up here in this table. So this is also an equals to, right? But we assumed A is n by n, right? So that means there are n columns in the matrix. For there to be one unique solution, the rank of A has to be n, and the rank of A augmented also has to be n. All right? So the rank of A has to equal the number of columns in A. Whereas, if there are infinite numbers of solutions, the rank of A has to be strictly less than n, And the rank of A augmented also has to be strictly less than n, but they have to be equal to each other. Any questions? Okay, so this is a pretty important table to keep in mind. A lot of true/false types of questions end up like requiring you to know the relationship between rank and the number of solutions. So that table should be helpful. So now let's talk about one last thing. We're talking about inverses. So this is section 2.6. So hopefully I can get this done in 4 minutes. Did so last. So definition, this is invertible. All right? And we say a matrix, an n by n matrix, so it has to be square, and we'll call it A, is invertible if there exists, that's this backwards E, a matrix B, and MX is my short form for matrix, such that, ST is such that, AB is equal to BA is equal to the identity matrix. Okay? So if there exists a B such that it commutes with A, and A times B is the identity matrix, we call B the inverse matrix. All right, and we denote it as A inverse. Okay, so for example, so how do we find the inverse? So let's let A equal 4, negative 2, 3, 1, negative 1, 0, negative 1, 0, negative 1. Find A inverse. I'm not going to do the calculation because that's what the videos on YouTube are for, but I'm going to show you how to set it up and how to do it. So the idea is the following. We're going to take this augmented matrix where we have A on the left-hand side. All right, so you write A down, put this vertical line in the middle, and on the right-hand side, you have the identity matrix of appropriate size. Okay? And the idea is, through row reduction, you want to reduce to reduced row echelon form. All right? RREF. And after you reduce to reduced row echelon form, what's going to happen is that you're going to get 1, 1, 1 on the left-hand side. And on the right-hand side, you're going to get your inverse matrix. All right? And I'm just going to tell you what it is. You can go home and try to see if you can get it. All right, negative 1, 2, negative 3, negative 1, 1, negative 3, and 1, negative 2, 2. All right, just hang on a little bit. I'm almost done. So again, so how do we do this? We started from A and the identity matrix, and we end up with the identity matrix on the left and A inverse on the right. So if you take A and you take A inverse and you multiply them, you're going to get the identity matrix. All right? And why does this work? Well, remember, I said reduced row echelon form was unique. Right? There's only one of them. So when I reduce this matrix to reduced row echelon form, everyone should get the same answer, no matter how you started off row reducing. Okay? All right, so that's that. Now, one last thing is this. Here's an application. So if you remember this guy, right, 4, negative 2, 3, 1, negative 1, 0, negative 1, 0, negative 1, times x1, x2, x3 is equal to 0, 1, negative 2. right? Remember this system of equations? This was example 2. All right, from above. All right, we can solve the system of equations using the inverse matrix of 4, -2, 3, 1, -1, 0, 0, 1, -1, 0, -1. So how we're going to do that is I can multiply the inverse matrix on the right-hand side, which is this guy up here, so what I'm doing is that on both sides of the equation, I'm multiplying the inverse matrix on the left. All right? And the reason why I have to do it on the left is because this matrix multiplication on the right-hand side has to have the appropriate dimension. Right? So this matrix multiplication here has to have the correct dimension. So I can't multiply it on the left. What's going to happen is, what is A inverse times A? It's the identity matrix, right? That's what I set up here. Okay? And so essentially these guys cancel, and you're going to be left with x1, x2, x3. And then on the right-hand side, if you do that matrix multiplication, you're going to get 8, 7, -6, which is exactly the solution we got before. All right, so take one. Don't leave without the homework for next week. All right, any questions? All right, so that's going to be that. A few announcements. So first of all, here's my website. This is where everything's going to be put up. You can take me out to lunch. This is a new thing this semester. I'm a senior. I'm not on a meal plan. I want as much free food as I can. So please, if you're free Monday, Wednesday, Friday, there's the link there. All the information is there. You can click on it. You can go read it. My recitation. So for my recitations only, if you're in my section, which it should be everyone in here, or most everyone in here, what I'm going to try to do is I'm going to try to pilot this smaller review session on Friday mornings. All right. So what's going to happen is there's going to be a form here at 1 p.m. today, which allows you to sign up for a smaller review session on 125. And I'm only taking about 8 to 10 kids per review session, and they're going to be an hour long. So it's going to be first come, first serve. You're going to have to register for yourself. I'm going to email the first 8, 10 people where we're meeting on Friday. And if you sign up, please be able to show up on Friday mornings. They're going to be at 9 a.m. The times are going to be listed there. Okay, Piazza's on the webpage here. Use it. That's where all the homework questions are going. Right-hand side are all the videos. So, for example, here you can find inverse matrices. I'll actually do the calculation out for you. So there's that. I'm going to have the recitation recordings right here on recitation review session recordings. This is where all my notes are. And then here's recitation 1. So I'm going to be uploading all those videos soon. And then here are the 240 notes. So if you have any questions with the vocab for chapter 2, you can read these. Big disclaimer, these are absolute garbage after chapter 4. So really only use them for chapter 2. They're unfinished for a reason. All right, so that's going to be it. That link will go live at 1 p.m. Make sure you leave with a homework. If you don't have one, please grab one. Turn in homework up here. All right, thank you. Okay.
But then I handed in the homework to another TA section.
Okay, that should be fine. So did you switch TAs, or did you switch Okay, you just switched TAs, but not not lecturers.
No.
Okay, so that should be fine this week.